All right, objective 1 in part 2 of module 3 is going to be taking the square root of perfect squares, negative numbers, and non-perfect squares. To begin this, I need to discuss what actually taking the square root of a number means. So let's look at the example, the square root of 9, right here. This radical sign, radical or square root goes hand in hand, means that there is a number that if multiplied by itself would give me 9 again. So it's technically the opposite of squaring a number. So in this case, the square root of 9 is 3, plus or minus 3. And we'll talk about the plus or minus in just a little second. And so what that means then is that 3 squared, or 3 times 3, equals 9. So technically the radical, or the square root, and then the power, so this square root here, and then the power of 2, inverse functions because they do the exact opposite to a number. If I take the square root of 9 up here, I get 3, and if I square 3, I will end up with 9. So taking the square root of a number is kind of like undoing squaring a number as well. So there's 3 types of situations you're going to encounter, 3 types of radicals you will encounter as you step into solving quadratic functions by taking a square root or by the square root method. I'm going to go over all 3 in this video. So after this video, you should at least be familiar with the 3 examples, and in the next video I'm going to show you how I'd approach mastering this if given homework or a quiz or a test, that type of thing. So the first one we're going to talk about are perfect squares. Perfect squares, when you solve and it's a perfect square, the radical is, the solutions are going to be rational. Please make note of that. We'll talk more about that when we discuss discriminants. So they're going to be rational. 2 examples I give. Number 1 is the square root of 121. Now, as we take the square root of a number, we need to know that there's going to be 2 solutions that exist, and I'm going to talk briefly about why. So the square root of 121 is a perfect square. Hopefully you have your perfect squares memorized. If not, you can always check with your calculator. I would always start there anyways. Check with your calculator first if you encounter a radical to see if it comes out as a perfect square. The square root of 121, though, is 11. Now, when you take the square root of any number, there needs to be 2 solutions. There needs to be a positive version and a negative version of that number. Let's talk about why. If I reverse this, so instead of the square root of 121 equals 11, let's say I reverse it to 11 squared equals 121, which it does. The positive version does, but in this case, the negative version of that number, negative 11 squared, also equals 121. That is why, because of the power of 2, technically what this is doing is saying negative 11 times negative 11 equals 121. When you multiply 2 negatives together, they cancel each other out and it becomes positive. That's why the positive version and the negative version need to be included in your answer. So please get in the habit of recognizing that every time you see a radical from now on, because you will encounter them a lot when solving quadratic functions. Now, another way this is written sometimes would be 11, the positive version, and then the negative version as well. Both answers are sufficient. The other example I have for this is just the square root of 49. In this case, the square root of 49 is 7. Hopefully you can remember that just doing mental math. But again, I need my plus and my minus 7. So those are perfect squares. Rational meaning that the number 7 is a rational number. It's a whole number and it's not 0, so it is a rational number. The number 11 is a rational number. Negative 7 is also a rational number. It's a whole number and it's not 0. That's the first situation, perfect squares where their solutions are rational. The second situation, let's move on. Non-perfect squares, so numbers that won't come out evenly when taking the square root. These solutions are what's called irrational, meaning their decimal goes on forever. So I'll write that as well. Decimal point goes on forever. In this case, though, we're not going to switch it to decimal form. We're going to leave it in what's called simplest radical terms. Or we're going to simplify it, or break it down is another way you can think about this. So in this case, if I were to take the square root of 32 on my calculator, that gives me 5.6568, and it goes on forever. I know that it's not a perfect square. So then I'm going to have to do what's called